is a walkthrough of Problem 1 on Exam 1 of Module 12 in the book Problem Solving Guide for Electromagnetism and Optics. Problem 1. There's a warehouse, faces the river, 2 doors. The distance between the doors is 15 meters. The doors are open. The walls of the warehouse have sound-absorbing material, so there's no echoes. Boat out here on the river sounds its horn. The 2 workers in the warehouse, A and B, are 20 meters apart. They're a distance of 50 meters from the wall with the doors. The doors are 15 meters apart. The workers are 20 meters apart. B is at the position of the 3rd minimum. What is the wavelength of the sound? So A is the central maximum, B is the 3rd minimum. We need the path difference at B's position. What is the path difference? Let's put those paths on the screen. There's from one door to B, and there's the sound from the other. Remember, the sound hits the front of the warehouse in phase. Now the sound's going to be shifted because of the path difference, and B's at the position of the 3rd minimum. It's given that the doors are 15 meters apart, and A and B are 20 meters apart. So we have the relevant distances that we need. We can calculate them. The vertical distance here is 12.5 meters. The doors are 15 meters apart. He's at the central max. The doors are 15 meters apart. That's 7.5. And A and B are 20 meters apart, so that's 12.5. So we have 12.5 and 50. We can use the Pythagorean theorem to get the R1. The distance to the faraway door is 32.5 meters this way, and of course 50 meters across. So R1, this path is 51.54 meters. The long path is 59.63 meters. And we can subtract them to get the path difference. So the path difference is 8.1 meters. The order of the interference is the 3rd minimum, which is a path difference of 2.5 wavelengths. So let's draw an isosceles triangle and get the path difference. So these 2 lengths of the triangle are the same. Here is the path difference right here. And this path difference is 8.10 meters, and this path difference contains 2.5 wavelengths. So 8.1 meters is 5/2 of a wavelength. We can solve for the wavelength. It's 3.24 meters. The wavelength is 3.24 meters. You have 1.5 wavelengths in the path difference. That's the answer to problem 1.